If triangle ABC is equilateral with side length 16, this is a tricky problem because our goal is to find the overlap, which is this area right here. And we've got to be a little bit creative with it because we never learned anything about how to find a sector like this where where we have it at it. We knew how to do it if you got something at E, but not with something at C. So actually, the best way to do this is to draw in our radius like this and realize that what we really have are three regions, two triangles, and then this region here, which is a sector. And so we actually got to go through and figure out each one of those. Since it's equilateral, then we can know that actually triangle 1 and triangle 2 are the same triangle. It's pretty easy to show that with E being the center of this. And so when we look at it, since E is the center, that means that this length is congruent to that length, is congruent to that length, and is congruent to this length. Since ABC has side length 16, and this is tangent, that means that this is a right angle, which means this is 8 and this is 8, because CD would be an altitude of an equilateral triangle, which is also a perpendicular bisector. And then we know this is 60 degrees there. And since we know that that is 60 degrees, then we know this is 30, which means this is 30, which means this is 120, which means this is 60, and this is 60. So our two triangles are these 30, 30, 120 isosceles triangles, and then our sector is a 120 degree sector. So let's start with the area of the sector. Well, an area of a sector is just the angle over 360 times the area of the circle. Well, the area of the circle we don't know yet, but since we have a 30, 60, 90 degree triangle right here, this is a short leg 8, so CD is 8 root 3, so the radius is 4 root 3. And if we take 4 root 3 squared times pi, that's going to get us the area of the circle. Multiply that times 120 over 360, which is 1/3. Well, 4 root 3 squared is 48 pi times 1/3 is 16 pi. And then we need to add to that these two triangles that I've got labeled 1 and 2. Well, if we just look at one of these triangles, we know that these are 4 root 3. And then we also know that this is a 30 degree angle, which means this is 60. And so the short leg is half the hypotenuse, so that's 2 root 3. And then the long leg is root 3 times the short leg, which is going to be 6. 2 root 3 times root 3 is 6, which means this is 6. So the area of this triangle is 1/2 height times the base, which gives me 12 root 3, but there's two of them, so it becomes 24 root 3. So the area of each of these two triangles, 1 and 2, are 12 root 3, and then the area of the sector, this region, is 16 pi, so the answer is 16 pi plus 24 root 3.